All right, so we're going to start with 20. Remember, if you don't need this problem, feel free. Don't feel like you're obligated. But do keep it down to a dull roar so that those who need it got it. All right, so for 20, we have a written, normal, everyday how, or why, excuse me. So folks, who is working with me on 20? Just so I know where to look and listen. Okay, good. So we've got this human-powered aircraft produced a power output about 0.3 horsepower, 746 watts. And how much energy did the pilot spend during the flight? And how many candy bars would the pilot have to consume to do the flight? All right, so let's think about it. So I think this is all about power and how that works with energy and work. So I'm going to start off by showing I understand what power is. So power is the rate that I do work. Let me make this a little bit lighter. The work done by the pilot. Well, the pilot goes into moving the aircraft. And or energy. I think that would be good. All right, so I think that's really all I need for my why. Okay. Do you need me to make it larger? Better? Worse? Oh, that's what I didn't get open. Alright, sorry about that delay there, folks. I need this equation. So I'm going to use this as I look at this problem. You know, my definition of power, the change in work or the change in energy over the change in time, that's what makes it that rate, right? Is that it's something over a change in time. So it's something compared to something else that makes it a rate. That it's a change compared to a change. So if I look here, they tell me the power of that is needed. For me, it's 700. It's 0.3 horsepower, and that each horsepower is 746 watts. So the first thing I'm going to do is figure out the power. And that's going to equal, how many, whatever part of a watt times how many watts, right? So that I'll get. I need that. Yep. How much power it has. And then that's going to go right in here for the amount of power. They tell me this, right? The time. And they ask me for, or we could do it this way. And they ask me for this. So if I have the power and I have the amount of time, I can solve for the amount the change in energy or the amount of energy that is needed from the information that I have. So I'll happily get the amount of energy. Does that make sense? In fact, I'm going to go like this. Forget about that one. Yeah. Good. Yep. Exactly. So, convert time to, what do you think? What units? What unit should we use for time? Seconds. Seconds. Because a watt, this is where I need to start. And the reason that we use seconds is because our power is in watts. So we need our power, we need the power in watts, which is a joule per second. Therefore, we need time in seconds. And remember, in 1 hour, there are 3,600 seconds. Right? So you convert whatever time is given. Let's see what time is given for me. I have, oops, I need to scroll. I have 2 hours and 49 minutes. So 1 hour is that. 1 minute, of course, is 60 seconds. So convert my time to seconds, convert my power to watts from horsepower, plug in, and I get the change of energy. Questions? All right, and then the second part they ask here, part B, how many candy bars, if there's this many calories per bar, would the pilot have to consume to be fueled up? So 1 cal, with a capital C, is equal to 1,000 small c calories, as defined in physics. And so they give you that 1 big C cal eventually equals 4,186 joules. Your answer to the first part, this is going to be in joules. Because your power is in joules per second, your time is going to be in seconds, you'll end up with joules there. So to do part B, you're going to convert from, let's say, I don't know, let's make up a number. 3297 joules. Made up number, right? So to convert there, I would do my 3297 joules and multiply it by, I want to keep the, so 1 big C calorie per 4,186 joules. And that'll give me my answer in big C calories. Whatever that number is. And then I can figure out, well, if each candy bar has 280 of those, how many candy bars do I need? Right? So in essence, I'm converting joules to candy bars. And then, so I do, let's see, then I convert again to candy bars. And there are, let's see, right, 1 candy bar per 280 big C calories. So in the beginning, I'm finding out how much energy it takes from the power and the time. Then part B is really just converting from joules. I first converted to big C cals and then to candy bars. But you could just go directly from joules to candy bars, right? With another conversion. Remember all the picket fences? Hopefully you did as chemistry students. That's really it. That's how you do that one. Yeah. That is, if you look at your problem here, in part B, it tells you 1 big C cal equals 4,186 joules. Yep. Other questions? Quandaries? Yes, Betty. Okay. All right, let me know when we're ready to go on to the next one, and we'll go on to 18 next. All righty, folks, on to 18, which was the next most requested one. And ironically, 18 is almost identical to 20. It's about power again. They just kind of swap things up. You know, in 20 they gave us the power, and they asked how much energy. Now they give us the power and the energy, and they say how long will it take, how much time. So my y for it is going to be kind of identical to before. So let's do this, a little blue there. So I'm going to show I understand power. Power is the rate that energy happens. The lower the power, the longer to do the same energy. The more the power, the less time needed. Yeah, there we go. And let's see if I still have that in clipboard. Oh, I do! So this time, they gave me the... I'm again using that definition of power. I'm going to get rid of that idea. This is given to me, the power. Now, nicely, this time, they give me power in watts. Anyone remember what is a watt in terms of joules and time? A watt is a joule per second. So now, and my energy is given to me in joules. Uh-oh, careful. They're looking for an answer in minutes. They're going to try to mess with me. So this is, and it's in watts, which is a joule per second. They give me this in joules. So after all this, I'm going to find my delta time, and it's going to be in seconds, and then make into minutes. How many seconds in a minute? 60. Yep, that's all there is to this one.